Welcome students. In today's session, we are going to learn about Bernoullis equation, which we come across in fluid mechanics. What is Bernoullis equation? Bernoullis equation is given by the expression P plus half rho V square plus rho GH is equal to constant. Actually, it is based on the principle of energy conservation, mechanical energy conservation. That is the sum total of the potential energy, the kinetic energy and the pressure energy at a point is constant. Suppose if I take a pipe like this, and there is some fluid going through the pipe. So I take this section, let us say section A, and I take this section, let us say section B. At both the sections, these values, the sum total of these three values will be a constant. That is Bernoullis equation. So how do we get this? In order to prove it, we have to take a datum line. This is called a datum line. Datum line has to be taken always for the calculation of this potential energy. Okay, so this is, let us say, situated at a height of y1, and this is at a height of y2, and here let us say the velocity of the flow is v1, and here the velocity of the flow is v2. Here the pressure is p1, and let us say here the pressure is p2. We know that the work done is given by the expression p dv, which is p into difference of volume, isn't it? So it is a difference of volume. So I will consider a small element dv. So I will keep it as work done is equal to p into dv. But work done is also equal to delta ke plus delta pe from this point to this point. Okay, so work done is equal to delta ke. What is delta ke? Delta k will be m v2 square minus v1 square plus mgh. Okay, so this is equal to, this is half into rho dv v2 square minus v1 square plus rho into dv into gh. If we equate these two terms, which is rho into p into dv, which is the work done, p into dv is equal to half into rho into dv into v2 square minus v1 square plus rho into dv into gh. So cancelling out dv from all these sides, left hand side and the right hand side, we are getting p is equal to half into rho into v2 square minus v1 square plus rho into gh. Okay, now this h is actually the difference. So here we should write h as y2 minus y1. Okay, h is actually the difference. I am considering this height. Which is y2 minus y1. If you rearrange the terms, you are going to get p1 plus half rho v1 square rho g y1 is equal to p2 plus half rho v2 square plus rho g y2. So the general equation we can write it as p plus half rho v square plus rho g into some height is equal to constant. So this is the Bernoullis equation.